Hey guys, welcome to your first notes video for core, YouTube core. Today we're going to be starting Key Concept 1 notes, and we're going to be starting by looking at Target 1A. Target 1A says, I can apply the properties of integer exponents to rational exponents. So really in this first target, we're really looking at exponents. So the first thing we're going to do is look at some vocabulary. If I see a term that looks like this, right, here, this is a term. The whole thing together is a term. The pieces of it also have different names. So this 10 we call the coefficients. It's the number in front. Right? The variable in this case, or whatever is being raised to the power, whatever actually has the exponent on it, is our base. And this number itself, right, the exponent, the power, the number that's up higher a little bit, right, that's what it's being raised to. It's being raised to that exponent. So those are our three main vocabulary words for this target: coefficient, base, and exponent. The first thing we're going to look at with exponents is combining like terms. Okay? When you combine like terms, so when adding or subtracting, depends, two numbers with the same base, right? So that number, that number, right, that's being raised to the power, that base has to be the same, and the exponent has to be the same. So the only thing that doesn't have to be the same is the coefficient, right? So when I'm adding and they have the same base and same exponent, all I do is add and subtract the coefficients. Everything else stays the same. So if you look at our first example here, I have x to the 8th and x to the 8th, right? Those are the same base and same exponent. Okay? So all I'm going to do is add the number in front. Remember, when there isn't a number in front, it's just 1, right? I have 1x to the 8th and another x to the 8th. I have a total of 2x to the 8th, right? 1 plus 1 is 2. Looking at example 2, right? I have x to the 4th and an x to the 4th, right? Here I have 5 of them, and here I have 2 of them, right? So if I have 5 of something and I take away 2, I'm only left with 3 of that something, right? Like I have 5 apples and I take away 2 apples, I'm left with 3 apples. So that x to the 4th stays the same. Same thing here. I have x to the 6th and x to the 6th. Those numbers are the same. I have 2 of them and I have 5 of them. Okay. That means I have a total of 7, right? X to the 6th. Again, it's like 2 apples plus 5 apples, a total of 7 apples. Be careful with example 4, right? If you look here, I do have an x squared. I don't have any other x squared. These are just x's, right? So that's like apples and oranges. I have 3 apples, 4 oranges, and 5 oranges, right? I have 3 apples, 4 oranges, and 5 oranges. So what do I have in total, right? Well, I still have just 3 apples. I still have just that 3x squared. Plus, well, now I have 4 oranges and 5 oranges for a total of 9 oranges. Right? So 4x plus 5x is a total of 9x. So that is adding and combining, or combining like terms, adding and subtracting, right? Go ahead and pause the video and try these problems on your own. Once you've worked on those problems, go ahead and start the video back up. We will be going over these 2 problems in class tomorrow. Alright, now that you've done those 2 problems, we're going to move to our next rule, which is the product rule. And the product rule talks about multiplying 2 numbers with the same base. Okay? So now, I don't care if their exponent is the same. They only have to have the same base. Right? Their exponent can be different, and their coefficient can be different. When I do that, I add the exponents. So let's look at our first example. Right? Example 1. I'm looking for the same base. So this has an x, this has an x, and this has an x, right? So I can actually multiply all of these because they have the same base, and I'm going to add their exponents, okay? So the base stays exactly the same. The base does not change. All I'm doing is adding those, okay? 2/3 plus 4/3 plus 1/3. If you struggle with adding your exponent, you can use a calculator. You have a calculator on your laptop. So you can use that TI Inspire calculator to add those if you have trouble with adding. Okay? So it's still, my base is still the same. My base hasn't changed. The only thing that's changed is I added those together. 2/3 plus 4/3 plus 1/3 is 7/3. That's x to the 7/3. Looking at example 2, right? Again, I want to look for the same base. I have a y here and a y here. Okay? So, and then I have my exponents. So my y stays the same, right? When I'm doing multiplication, I don't change that base. I'm simply adding those two numbers together. Okay? Again, y stays the same. My exponent is 1. The one thing is if I have something to the first, it's really just the same as saying I have that. So y to the first is really just y. I don't have to write that 1. It's understood to be there. Okay, so be careful with some of those. Looking at example 3, now I have more than one thing going on. I have an f and an f. Those are the same base. But I also have a g and a g. Okay? So looking at f, I want to look at the exponents for f separately from when I look at g. Okay? So for my base of f, right, f to the 1/4 times g to the 1/3 times f to the 5/4 times g to the 2/3. For my base of f, right, I just add the f exponents, 1/4 and 5/4. For my base of g, I just add my g exponent, 1/3 plus 2/3. 1/3. And then it's the same thing, you're just adding those, right? F is then to the 6/4, right? 1/4 plus 5/4 is 6/4. And for g, I keep that base the same. 1/3 plus 2/3 is 3/3. So then all I'm doing is I'm reducing. And remember, your TI Inspire calculator will help you reduce and help you with those fractions. Okay? So 6/4 is really 3/2. And 3/3 is 1, which then it's just like what we did over here with the y. It's just g. All right, example 4 gets a little different because I have numbers, right? Now I have those coefficients out in front. So we're going to do something a little bit different with the coefficients. I'm going to start with looking at my coefficients. I have 3, 2, and 4. And technically, I have a 1 in front of the d there, right? If there's not actually a number in front, it's just 1. So I pull all of those out. So I'm still multiplying the coefficients. Okay, I multiply coefficients. Then I'm still doing the same thing. I'm looking for my same base. I have a base of c here and a base of c here. And then those exponents are 2/5 and 3/5. Then I have a base of d and a base of d. And I have 1/2 and 1/4. So my base stays the same. It's just c. I add those two exponents, 2/5 plus 3/5. My base, that base of d, stays the same. I just add my exponents. Okay? And then you're just kind of simplifying. 3 times 2 times 4 times 1, right? Is 24. Right? And again, you can use your calculator to help you with some of that multiplication. Again, I still have that same base. And I just added those exponents. 2/5 plus 3/5 is 5/5. I still have that same base. 1/2 plus 1/4 is 3/4. So then 24, 5 over 5 is really just 1. So that's really the only thing that changed. That c is just to the first power, and just like we did up there, right, you don't have to write that 1 next to it. It's really just c. We're going to look at 2 more examples today. Right, so if I look at our first example, I have 3x to the 4/5 and 2x to the 2/5. So let's highlight everything that we have. I have my coefficients, right? Those are the numbers out in front. Then I have just one base, right? X is my only base. And then I have 4/5 and 2/5 as exponents to that base. So remember, when you have that exponent out in front, those coefficients out in front, you have to multiply those separately. So I have 3 times 2 times, right? And then I take whatever base I have, so that's just x. And then I add those exponents. So I have 4/5 plus 2/5. Okay. So then I'm just simplifying. 3 times 2 is 6. That base still stays the same. And 4/5 plus 2/5 is 6/5. And that's my final answer. 6x to the 6/5. All right, let's look at our next example. Looking at example 6, I have 2x to the 3/7 times 3y to the 4/3, and then 3x to the 2/7 times 4y to the 2/3. So again, I'm going to start with finding my coefficients. And then my bases. So I have x here and an x here. And then I have a y here and a y here. So for this one, I do have 2 different bases. So be careful with that. So for my exponents are 3/7 and 2/7. And for my y, my bases are 4/3 and 2/3. So again, I'm going to start by pulling out all those coefficients. I have 2 times 3 times 3 times 4. Then, right, start with your first base, which is x. And x is raised to the 3/7 and the 2/7. Right, so I add those. Times my other base is y. And y is raised to the 4/3. Four thirds and the 2/3. So that is my final answer. 2 times 3 times 3 times 4. If you multiply all of those together, you should get 72 in your calculator. Then I have x. 3/7 plus 2/7 is 5/7. And then for y, 4/3 plus 2/3, again, you can always use your calculator to help you out. 4/3 plus 2/3, and you do get 2 there, right? It's 6/3 or 2. All right, that's all the problems we're going to go over. Again, please go ahead and do the on your own problems. We will go over those tomorrow in class. Have a wonderful day.